Hello students, welcome to Diksha Karnataka YouTube channel. In this video, I am going to discuss top 30 questions in electromagnetic induction. So electromagnetic induction is a medium weightage chapter for COMEDK 2024. So if you analyze last 5-year papers, so every year they asked 3 to 2 questions from this chapter. Okay, so this one is the very easier chapter. You have to remember only 3 to 4 formulas. Okay, from those formulas only they are going to ask the questions. Okay, so if you are able to solve these questions, definitely you will be able to counter these kind of questions in the exam. Okay, so let's start. Question number 1. Mutual inductance of two coils can be increased by. Okay, so let us write the mutual inductance of the coil. So what is the mutual inductance of the coil? M is equal to mu naught N1 N2 into I divided by L, right? So this is the mutual inductance of the coil, isn't it? So we can increase the mutual inductance of the coil by increasing the number of the coils, right? Number of turns in the coils, isn't it? So option A says decreasing the number of turns in the coils. Wrong. We have to increase the number of turns in the coils. Increasing the number of turns in the coils. Correct. Winding the coils in the wooden cores. Wrong. None of these. Again, this one is also wrong. So the correct option is B. Okay. So we have to increase the number of turns in the coils. Yeah. Question number 2. The variation of induced EMF with time t in a coil if a short bar magnet is moved along its axis with the constant velocity is best represented as. Okay, so this bar magnet moved along inside this coil, right? So when the bar magnet moved along inside this coil with constant velocity, what happens? Magnetic flux changes with the time, right? Magnetic flux changes with the time. So induced EMF will be in the opposite direction, isn't it? Induced EMF will be in the opposite direction. So the correct option has to be B, right? First, induced EMF will be in opposite direction. Then first here it will be negative and positive, right? So then negative and positive, isn't it? So the correct option is B. Here negative, this will be positive. Okay, so the correct option is B. Question number 3. The normal magnetic flux passing through a coil changes with the time according to the equation phi equal to 60 square minus 5t plus 1. What is the magnitude of the induced EMF at t equal to 0.253 second and resistance 10 ohm? Okay, we need to find magnitude of the induced EMF in the coil, right? Yeah. Magnitude of the induced current, not induced EMF. So induced current I equal to E divided by R. What is E? Induced EMF. R is resistance of the coil. So I is equal to induced EMF is magnitude of d phi by dt whole divided by R. So let us find magnetic flux. Okay, rate of change of magnetic flux. Okay, now d phi by dt is equal to, so what is the differentiation of phi with respect to t? Here differentiation of 60 square minus 5t plus 1, right? So what is the differentiation of 60 square? 12t, right? So 12t. What is the differentiation of minus 5t? Minus 5. What is the differentiation of 1? 0, right? So we need to find magnetic flux, rate of change of magnetic flux, that is induced EMF in the coil at time t equal to 0.253 second, right? So d phi by dt at time t equal to 0.253 second is equal to 12 into 0.253 minus 5. Okay, so now I is equal to here 12 into 0.253 minus 5 divided by R equal to 10 ohm. R equal to 10 ohm, right? R equal to 10 ohm. So now solve this, you will get I equal to 0.8 ampere, approximately equal to 0.8 ampere. Okay, approximately equal to 0.8 ampere. So the correct option is A. Understood? The correct option is A. Yeah. Question number 4. A solenoid has an inductance of 10 Henry, that is L is equal to 10 Henry, right? And the resistance of 2 ohm are equal to 2 ohm. Connected to a 10 volt battery, how long will it take along the magnetic, how long will take, okay, will it take for the magnetic energy to reach the 1 by 4th of maximum value? Okay, so we need to find time taken by the how long solenoid will take, the magnetic energy to reach the 1 by 4th of its magnetic maximum value, right? Okay, what is the maximum value or maximum energy stored in the inductor? That is half L into I max square. Okay, so I max is I naught. Okay, I max, maximum current in the coil is here I naught. Okay, so now at any time t, the current in the coil is I is equal to I naught into 1 minus e to the power minus t divided by tau, right? Minus t divided by tau. So what is tau? Time constant, right? So time constant tau is equal to R by L, right? Sorry, L by R, isn't it? L by R, right? L by R. So what is tau? Tau equal to L is 10 Henry divided by R, that is 2 ohm. So which is equal to 5, right? 5 second. So it is a time constant, right? So it is in second. So we need to find the value of t, right? Okay. So now here I equal to I naught is the maximum current in the coil, right? So I naught into 1 minus e to the power minus t divided by 5, right? Minus t by 5. So what we need to find here, we need to find how long the solenoid will take for the magnetic energy to reach 1 by 4th of its magnetic value, right? So U is equal to 1 by 4th of its magnetic value, right? Maximum value, not magnetic value, maximum value, isn't it? So now here we need to find time t, right? So now U is equal to half, 1 by 4 into U max is half into L into I naught squared. Okay, half into 1 by 4 into half into L into I naught square, right? So now here so U is equal to half into L into I square, right? I is the current in the coil, okay, at time t. So which is equal to 1 by 4 times half into L into I naught square, right? So now 1 by 2 times L will get cancelled. So now I equal to I naught by 2, right? I equal to I naught by 2. So here the current in the coil is I naught by 2, which is equal to I naught into 1 minus e to the power minus t divided by 5, right? So now I naught will get cancelled, isn't it? So now e to the power minus t divided by 5 is equal to 1 minus 1 by 2, that is 1 by 2, right? Or you can write it as e to the power t by 5 is equal to e to the power t by 5 is equal to 2. So now take antilog on both sides. So here the log of e to the power t by 5 is t by 5, which is equal to ln of 2, natural log of 2, right? Okay. So finally time t is equal to 5 into ln of 2. So it will take this much time, that is the solenoid will take this much time, t equal to 5 of ln of 2, this much time to reach the 1 by 4th of its maximum value, right? So the correct option is here C. Okay, yeah. Question number 5. In a coil of resistance 100 ohm, a current is induced by changing the magnetic flux through it. Okay, so here the resistance of the coil is 100 ohm and current induced by the changing the magnetic flux through it as shown in the figure. Okay, so this is the current and time graph, right? The magnitude of the change in flux through the coil. Okay, we need to find the magnitude of the change in flux through the coil, right? Okay, so we know that here the current I is equal to induced EMF divided by R, right? Induced EMF divided by R. So now what is induced EMF? Induced EMF is rate of change of magnetic flux or change in magnetic flux over change in time. So now I equal to delta phi divided by delta t into R. Okay, delta phi divided by delta t into R. We need to find magnitude of the change in magnetic flux, right? So delta phi is equal to I into R into delta t, right? I into R into delta t. So here they have given current versus time graph, right? So therefore here the area under this graph or this curve or this straight line is change in magnetic flux, right? Area under this line is change in magnetic flux. So now delta phi is equal to area under IT graph, right? IT graph. So now delta phi is equal to area under IT graph into R, okay, into R. So now delta phi is equal to area under IT graph, that is area of this right angle triangle, right? So what is the base? 0.5. What is the height? 10. So 1 by 2 into 0.5, that is 1 by 2 into 10. So 2 5s are 10, then 2.5. Now area under this line is 2.5, okay. So 2.5 into R. R is, here what is the value of R? 100 ohm. So now delta phi is equal to 250 Weber. Okay, 250 Weber. So the correct option is C. Okay, correct option is C. Understood? Yeah. Question number 6. The energy stored in the magnetic field if current of 5 ampere produces a magnetic flux of 2 into 10 to the power minus 3 Weber through a coil of 500 turns is. Okay, so we need to find the energy stored in the magnetic field if the current 5 ampere produces a magnetic flux of 2 into 10 to the power minus 3 Weber through the coil of 500 turns, right? Okay, so what is the energy stored in the magnetic field, right? Or energy stored in the coil, U equal to half Li square, right? U equal to half into L into I square, right? But we don't know the value of L, right? That is the self-inductance, isn't it? But we know that L into I is equal to N into phi, right? L into I is equal to N into phi. Magnetic flux is given, right? Number of turns is given and the current is also given. Let us find L. So L is equal to here N, right? N is 500 turns or okay, 1 minute. Here let us write L equal to N phi divided by I. N phi divided by I. So now the magnetic energy U equal to half L is N phi divided by I into I square. So I will get cancelled. So U equal to half N phi into I. So now substitute the values. U equal to half N is 500, 5 is 2 into 10 to the power minus 3 and I is 5. So now 2 will get cancelled. So U is equal to 500 into 5 is 2500, right? 2500 into 10 to the power minus 3 is 2.5. So 2.5 joule. The correct option is A. Okay. Correct option is A. Yeah. Next question. Question number 7. A coil having 500 square loops. Okay. N is equal to 500. Of side 10 centimeter. Okay. L equal to 10 centimeter. The side is 10 centimeter. That is 0.1 meter. Is placed normal to magnetic field. Okay. It is placed normal to magnetic field. Okay. That is the plane of the coil is normal to the magnetic field, which increases at rate 1 Tesla per second. Magnetic field increases at the rate 1 Tesla per second. The induced EMF is, okay, we need to find induced EMF, right? Here, dB by dt, it increases at the rate 1 Tesla per second. 1 Tesla per second, right? So now induced EMF, E is equal to rate of change of magnetic flux, N into d phi by dt, magnitude of the induced EMF, which is equal to N into d phi by dt. Okay, so now here E is equal to N, right? Okay, N into what is phi? Magnetic flux. Magnetic flux is B dot A, magnetic field vector dot area vector, right? Here the direction of the area vector and the magnetic field vector both are in same. Okay, both are same. So therefore, the angle between A and B is 0 degree. So BA cos theta, right? In scalar form, B vector dot A vector is BA cos theta. Theta is 0 degree, so it is just BA, right? So N into d by dt of B into A, right? B into A. So now E is equal to N A dB by dt. Now E equal to N is 500 and A is 0.1 squared, that is 10 to the power minus 2 into dB by dt is 1. So E equal to 5 volt. The correct option is D. Okay, correct option is D. Understood? Yeah. Next question. Question number 8. A coil of wire of a certain radius has 100 turns, that is N equal to 100. Okay, and a self-inductance of 15 millihenry. L equal to 15 into 10 to the power minus 3 Henry, right? The self-inductance of 500 turns will be, okay, we need to find the self-inductance of the 500 turns, right? Okay, we know that self-inductance is directly proportional to the number of turns in the coil, right? Self-inductance is directly proportional to number of turns in the coil. Here the current through the coil is same, okay? Here the current through the coil is same. So now L1 divided by L2 is equal to N1 divided by N2, right? L1 divided by L2 is equal to N1 divided by N2. Remember here L into I equal to N into phi, right? N is, so L is directly proportional to N, right? So now L1 is 15 millihenry, right? Okay. So here we need to find N2, isn't it? Sorry, we need to find L2, okay? So now L2 is equal to N2 divided by N1 into L1, right? Now L2 is equal to N2, N2 is here 500, N1 is 100 into L1 is 15. So 100 will get cancelled. So L2 is equal to 75 millihenry. The correct option is A. Okay, the correct option is A. Understood? Yeah. Okay. Yeah. Next question. Question number 9. A coil of 100 turns carries a current of 5 milliampere. Okay. N is 100, I is equal to 5 milliampere and creates magnetic flux of 10 to the power minus 5 Weber. The inductance is, direct question, right? So we know that L into I equal to N into phi. This is the relationship between self-inductance, current and the magnetic flux, right? So we need to find L. So L equal to N phi divided by I. Now L equal to N is 100, phi is 10 to the power minus 5, and what about the I? I is 5 into 10 to the power minus 3. So now 5 20s are 100, 10 to the power minus 5 by 10 to the power minus 3 is 10 to the power minus 2, right? So now L is equal to 20 into 10 to the power minus 2 is 0.2, right? 20 into 10 to the power minus 2 is 0.2 Henry, isn't it? 0.2 Henry. So we have to convert it into millihenry, isn't it? So here this will be in millihenry. So this will be 200 millihenry, isn't it? Okay, 200 is not given. So option D is the correct answer. Okay. Option D is the correct answer. N equal to 100, right? 100 into 10 to the power minus 5, that is 10 to the power minus 3, right? 10 to the power minus 3 by 5. Okay. Yeah, correct. None of this is the correct answer. Actually 200 millihenry. Okay. Yeah. Question number 10. Two similar circular loops carry equal currents in the same direction on moving coils further apart. The electric current will. Okay, so what happens to the electric current? What happens when the coil carrying similar current, two similar coil carrying the same current moved away from each other, right? Here the current is I and I, right? So when these two coils moved away from each other, what happens? The magnetic flux through these two coils will decreases, right? Magnetic flux through these two coils will decreases, isn't it? So if magnetic flux decreases, what happens? Induced current will be produced, right? Isn't it? So induced current opposes the decrease in magnetic flux or decrease in magnetic field, right? So therefore, the current here, the induced current will be, or the current in the coil will be increases. Electric current will be increases. So the correct option is C. Okay. Question number 11. The magnetic flux through a coil is 4 into 10 to the power minus 4 Weber per meter square. At time t equal to 0, it reduces to 10% of its original value. Okay. Magnetic flux through the coil is given, okay, at time t equal to 0, and it reduces to 10% of its original in t seconds. Okay. So here initial magnetic flux is 5, okay, at time t second. Now the magnetic flux, this is phi I, phi f is equal to it reduces 10%, right? Isn't it? So that is phi minus 0.1 times phi, right? Phi minus 10 divided by 100 times phi. So phi f is equal to 0.9 times phi. Okay. Phi I equal to phi. If the induced EMF is 0.02 millivolt, then the time t is, okay, we need to find the time t, right? So induced EMF E is equal to minus d phi by dt, rate of change of magnetic flux. Negative sign represents the polarity, right, or the direction of the EMF. Now here we need to find t, right? Isn't it? Here minus d phi by dt is rate of change of magnetic flux or change in magnetic flux over change in time. So now E is equal to minus d phi is change in magnetic flux, that is final magnetic flux minus initial magnetic flux divided by time t, final time t minus initial time 0. So now E is equal to phi f is 0.9 phi, right? So 0.9 phi minus phi, your minus is there, divided by t. So now t is equal to, your phi minus 0.9 phi is 0.15, right? 0.15 minus 0.15, okay, minus into minus plus. So 0.15 divided by E, that is 0.75, sorry, 0.72 into 10 to the power minus 3. So now T is equal to 0.1 into phi is 4 into 10 to the power minus 4 divided by here 7.2, right? 7.2 into 10 to the power minus 4. So now solve this, okay? Solve this, you will get T equal to 0.5 second, 0.5 second. So the correct option is here B. Okay, correct option is B. Understood? Yeah. Question number 12. According to Lenz's law of electromagnetic induction, option A says the induced EMF is not in the direction opposing the change in magnetic flux so as to oppose the cause which produces. Okay, so here the induced EMF is not in the direction opposing the change in magnetic flux. No, this is wrong, right? Isn't it? Here it is in the direction. Okay, now it is in the direction opposing the change in magnetic flux, right? Isn't it? It opposes the change in magnetic flux, right? So option A is wrong. Option B, the relative motion between the coil and the magnet produces the change in magnetic flux. Yeah, correct. Right? Second one is correct. The third one, only the magnet should be moved towards coil. No, this one is wrong, right? Either coil can move towards magnet or magnet can move towards coil. Option D, only the coil should be moved. Okay, this one is also wrong. The correct option is B. Okay, yeah. Question number 13. A magnetic flux is total number of magnetic field passing normally through a given area, right? So the correct option is A. Sorry, correct option is C. Question number 14. A straight conductor of length 2 meter moves with the velocity of 2 meter per second in a magnetic field of induction 0.5 Weber per meter square and perpendicular to 8. The EMF induced in the conductor. Here the motional EMF, right? This one is from motional EMF. E equal to B into L into V sin theta. What is theta? Theta is angle between P and V. So here it is moving, the wire is moving perpendicular to the magnetic field. Okay, so E is equal to BLV sin 90 degree. Sin 90 degree is 1. So B is here 0.5, L is 2, V is 2. So E equal to 2 volt. The correct option is A. Question number 15. A circular disc of radius 0.2 meter, okay, circular disc of radius 0.2 meter, here R equal to 0.2 meter, is placed in a uniform magnetic field of induction 1 divided by pi Weber per meter square in such a way that its axis makes an angle of 60 degree. Okay, its axis makes an angle of 60 degree. Here, this is the magnetic flux, magnetic field, okay, magnetic field, and here the axis of the coil makes an angle 60 degree with the magnetic field. Here this is the axis of the coil, okay, it makes an angle 60 degree with the magnetic field. So this is the direction of the A, this is direction of the B. With B vector, the magnetic flux linked with the disc. Okay, we need to find magnetic flux linked with the disc. That is the number of magnetic field lines passing normally through this plane, the plane of the circular disc, right? Yeah. So magnetic flux phi is equal to BA cos theta. Theta is angle between B and A, that is 60 degree. So phi equal to B is 1 by pi into A. Here A is radius of the disc is given, right? So the area of the disc will be pi into r square, right? Pi into r square, that is 0.2 squared. 0.2 squared is 2 into 10 to the power minus 2 into cos theta. Theta is 60 degree. So 1 by 2. Cos 60 degrees 1 by 2. So 2 will get cancelled. Pi will get cancelled. So phi is equal to 0.01 Weber. 0.01 Weber. The correct option is B. Okay, yeah. Question number 16. When a current carrying conductor is placed in a magnetic field, it experiences a force, the direction of which is given by. The direct question, right? So when you place the current carrying conductor in a magnetic field, what happens? It experiences force, right? So the direction of the force can be found by using Fleming's left hand rule, right? So Fleming's left hand rule states that here the thumb represents the force acting on the conductor, and here the index finger represents the field and middle finger represents the direction of the current or the current, isn't it? So by the left hand rule, Fleming's left hand rule, you can find the direction of the force acting on the conductor when the current carrying conductor placed in a magnetic field. Okay. Question number 17. The distance between the rails is 2 meter, which is parallel to Earth magnetic meridian. Okay, distance between the two rails is 2 meter. Okay, 2 meter, and which is parallel to Earth's magnetic meridian. Vertical component of the Earth magnetic field is 1.25 into 10 to the power minus 4 Tesla. That is, this is the direction of the magnetic field. Okay, is B equal to 1.25 into 10 to the power minus 4 Tesla. If the speed of the train is 4 meter per second, okay, here the train is moving, okay, speed of the train is V equal to 4 meter per second, then the induced EMF across the axle, okay, induced EMF across the axle, these two, right? So here, sorry, induced EMF across the axle, these two, isn't it? Not on the rail, these two, axle, right? So here induced EMF E equal to B into L into V sin theta. Theta is angle between V and B, that is 90 degree. Magnetic field and V both are perpendicular to each other, right? So 90 degrees. So E equal to BLV. That's it. So B is here 1.25 into 10 to the power minus 4, and L is 2 meter, and V is 4 meter per second. So now solve this. Here E equal to 1.25 into 2 is 2.5, 2.5 into 4 is 10. So 10 into 10 to the power minus 4 is 10 to the power minus 3, 10 to the power minus 3 volt. The correct option is D. Okay, yeah. Question number 18. The magnetic flux of 3 into 10 to the power minus 4 Weber passing through a coil of 100 turns. N is given, phi is also given, right? If EMF induced in the coil is 1.5 volt, the time interval will be. So EMF induced in the coil E equal to magnitude of N into delta phi divided by delta T. That is change in magnetic flux over change in time. Now delta T is equal to N divided by E into delta phi. Delta phi is change in magnetic flux. So now delta T is equal to N is 100 divided by 1.5 into delta phi is 3 into 10 to the power minus 4. So now delta T is equal to 3 by 1.5 is 2, 200, 200 into 10 to the power minus 2 is 2 into 10 to the power minus 2, that is 0.02 second. The correct option is C. Okay, yeah. Question number 19. The unit of inductance is, okay, so let's find. Here we know that L into I equal to N into phi. N is unitless, right? Number of turns doesn't have any unit, right? Okay. So now differentiate both sides with respect to t. So now N into di by dt is equal to N into d phi by dt. N into d phi by dt. So what is d phi by dt? Rate of change of magnetic flux, that is induced EMF. So L equal to E divided by di by dt, right? Di by dt. So now L equal to E is volt, okay, volt, and dt will go to the numerator, right? So that will be second divided by di, that is ampere. So unit of the self inductance is volt second ampere. Volt second divided by ampere. So the correct option is A. Okay, yeah. Question number 20. A wire of length 2.5 kilometer. Okay, length of the wire is 2.5 kilometer and resistance of the wire is also given, that is 35 ohm, has fallen from a height of 10 meter in the Earth's horizontal field of 10 to the power minus 2 into 10 to the power minus 5 Tesla. Okay, so let's imagine the situation. Here this is the wire, right? So this wire, a 2.5 kilometer wire, falls from, what is the height? Fallen from a height of 10 meter. Okay, it falls from the 10 meter height, isn't it? Right? So Earth's horizontal magnetic field is given. Here the motion of the wire is perpendicular to the magnetic field, right? So this is the direction of the Earth's magnetic field, horizontal Earth's magnetic field, isn't it? So motion of the wire is perpendicular to the Earth's horizontal magnetic field. Okay, so this is the motion of the wire. We need to find current through the wire, right? Okay, so current through the wire, I equal to EMF produced in the wire divided by R. So let us find induced EMF in the wire. R E equal to B into L into V sin theta. What is the theta? Theta is angle between motion of the wire, that is velocity of the wire, and magnetic field. Magnetic field is Earth's horizontal field, right? So both are perpendicular to each other. So theta equal to 90 degrees. So E equal to BLV, right? E equal to B into L into V. We know the value of B. We know the value of L, that is the length of the wire, but we don't know the value of the V, right? Length of the wire is 2.5 kilometer. But we don't know the value of V, isn't it? Okay, let us find the value of V. Initial velocity of the wire is 0, right? So apply third equation of motion. V square equal to U is 0 plus 2gh. Now V equal to root of 2gh. Root of 2 into g is 10 into 10. So now V equal to here 2 into then 10 into 10, 100, right? Isn't it? So root of 10 into root of 2, 10 into root of 2 meter per second, right? So this is V square. So now E equal to B, here B is 2 into L is 2.5 into 10 to the power 3 into V is 10 root 2 meter per second. This is E. So then I is equal to 2.5 into 2 is 5, 5 into 10 is 50. So 50 into root 2 into 10 to the power 3 divided by R, that is 30 pi. Okay, so then solve this. Okay, solve this, you will get 0.02 ampere. Okay, 0.02 ampere. Understood? Here B is 2 into 10 to the power minus 5. Okay, 10 to the power minus 5 is there. Yeah, 0.02 ampere. The correct option is C. A coil of wire of 1000 turns has self-inductance 120 millihenry. So here, let's say this is L1 and this is N1. The self-inductance of the coil 250 turn is, this is N2. We need to find the value of L2. We know that the self-inductance of the coil, with relationship between self-inductance, current and magnetic flux of the coil, magnetic flux through the coil, right? So that is L into I equal to N into pi. So we need to find L2, right? So from this I can conclude that L is directly proportional to N, right? So now L2 by L1 is equal to N2 by N1. Now L2 is equal to L1 into N2 by N1. Now L2 is equal to L1 is 120 millihenry into N2, N2 is 250 by N1, that is 1000. So 10 will get cancelled, 25 4s are 100, 4 3s are 12, so this will be 30. So L2 equal to 30 millihenry. The correct option is A. Okay. Yeah. Question number 22. A bicycle generator creates 1.5 volt. Okay, it creates 1.5 volt at 15 km per hour, EMF generated at 10 km per hour is. So we know that induced EMF in the generator is equal to, here is directly proportional to V, right? Induced EMF produced in the generator is directly proportional to V, right? So now E2 divided by E1 is equal to V2 by V1. Now E2 is equal to E1 into V2 by V1. Now E2 is equal to E1. E1 is 1.5. V2 is 10 km per hour and V1 is 15 km per hour. Now this will be 10 will get cancelled. Okay, so E2 is equal to 1 volt. Okay, the correct option is D. Understood? Yeah. Question number 23. If a change in current of 0.01 ampere, that is 10 to the power minus 2 ampere or 10 millihenry, okay, sorry, 10 milliampere in one coil produces a change in magnetic flux of 2 into 10 to the power minus 2 Weber. Delta phi equal to 2 into 10 to the power minus 2 Weber, and here change in current, that is delta I, is equal to 10 milliampere, right? Yeah, 2 into 10 to the power minus 2 Weber in another coil. Then the mutual inductance between the coils is, we need to find the mutual inductance between the coil, right? So we know the relationship between mutual inductance, current and number of turns and then magnetic flux, right? So that is M into I is equal to N into phi, right? So now M equal to N into phi divided by I, N into phi divided by I. So phi is change in magnetic flux, okay, that is delta phi, okay. And what about the N? N value is 1, okay. I is 10 milliampere. So now M is equal to N is 1, phi is 2 into 10 to the power minus 2 divided by 1 into 10 to the power minus 2. So M equal to 2 Henry. The correct option is C. Okay. Yeah. Question number 24. An aeroplane is flying horizontally with the velocity of 360 km per hour. That is 100 meter per second, right? So 360 into 5 by 18. So this will be 20, right? 20 into 5 is 100. So 100 meter per second. This is the velocity of the aeroplane. The distance between the tips of the wings of the plane is 50 meter. Okay. So the length of the wing, the total length will be 50 meter. The vertical component of the Earth's magnetic field is 4 into 10 to the power minus 4 Weber per meter square. The induced EMF is, okay, we need to find the induced EMF, right? So this is the aeroplane, okay, and these two are the wings. It is moving with 100 meter per second, that is wings are also moving with 100 meter per second, right? So this is the direction of the vertical component of the Earth's magnetic field, that is 4 into 10 to the power minus 4 meter per second. Oh, sorry, 4 into 10 to the power minus 4 Weber per meter square. Question number 24. An aeroplane is flying horizontally with the velocity of 360 km per hour, that is V equal to 100 meter per second. Okay, the distance between the tips of the wings of the plane is 50 meter, that is L equal to 50 meter. The vertical component of the Earth's magnetic field is 4 into 10 to the power minus 4 Weber per meter square. Okay, let's draw the diagram. This is the aeroplane. These two are the wings. Aeroplane moving with velocity 100 meter per second. The length is 50 meter. This is the direction of the magnetic field, vertical component of the magnetic field. 4 into 10 to the power minus 4 Weber per meter square. the induced EMF is simple one, right? So induced EMF E equal to BLV sin theta. Theta is angle between B and V, that is 90 degree. So E equal to B into L into V. So E equal to B is 4 into 10 to the power minus 4 into L is 50 into V is 100. So 100 into 10 to the power minus 4 is 10 to the power minus 2. Okay, 50 into 4 is 200. So 200 into 10 to the power minus 2 is 2. So E equal to 2 volt. Induced EMF or potential difference between the tip of the wings is 2 volt. Option C is the correct answer. Okay, sometimes they won't ask induced EMF. Okay, they will ask what is the potential difference between the ends of the wings, right? So again, you have to follow this method. Yeah. Question number 25. The inductance in a coil plays the same role as, the direct question, right? So inductance in the coil plays the same role as inertia in mechanics, right? So why? Because inductance in the coil, so that inductance means here it opposes the coil, it opposes the electric current in the circuit, isn't it? So here this is the coil, right? So if the current flowing through the coil is I, what happens? The magnetic field will be produced, right? So if current is increasing, then what happens? The magnetic flux through the coil will also be increases, right? So to oppose the increase in magnetic flux, what happens? Induced current will be produced, right? Isn't it? So we know that L into I is equal to N into phi, right? So this is the relationship between inductance, current and magnetic flux, right? So inductance in a coil plays the same role as inertia in mechanics. Okay, inertia in mechanics. So what is the inertia in mechanics, right? Inertia means it's a property of the matter or object. So it opposes its state, right, or its position, right? If it is moving, if it is moving, then the object tries to move with the uniform speed only, right? So it opposes if you applied the force in opposite direction, what happens? It opposes that force, right? It will try to move in this way. Question number 25. The inductance in a coil plays the same role as, inertia in mechanics. That's it. Why? Because inductance in the coil which opposes the electric current in the circuit, right? Isn't it? So it is same as, or the same role as inertia in mechanics, right? So the correct option is 25. Sorry, correct option is A. Question number 26. The mutual inductance between the two coils depends upon. Okay, the medium between the coils, this one is also correct, right? So we know that mutual inductance M is equal to, between the two coils, right, mu naught into mu r into N1 N2 into I divided by L, right? So it depends upon the medium between the two coils, and then the separation between the coils only. This is also correct. If the separation between the coils increases, what happens? Mutual inductance decreases, right? If the separation between the coils decreases, mutual inductance will be increases. Yeah, this one is also correct. Option C, both the medium and separation. Yeah, the correct option is C. Okay, not A and B, because A and B both are correct, right? Isn't it? The normal magnetic flux passing through a coil changes with time according to the equation phi equal to 3t cube minus 2t. What is the magnitude of the induced current at t equal to 1 second and resistance 10 ohm? Okay, so we know that induced current I equal to induced EMF divided by R. So I equal to induced EMF is rate of change of magnetic flux, d phi by dt divided by R. So I equal to, now d phi by dt, right? d phi by dt is 9t square minus 2, right? 9t square minus 2 at t equal to 1 second here divided by 10 ohm. So now I equal to 9 into 1 is 9, 9 minus 2 is 7, right? So 7 divided by 10 ampere. So now I equal to 0.7 ampere. The correct option is B. Question number 28. A current of 2.5 ampere flows through a coil of inductance 5 Henry. The magnetic flux linked with the coil. Direct question, right? We know the relationship between self-inductance, current and magnetic flux, that is phi equal to L into I. Phi equal to L is 5 and I is 2.5. So solve this, you will get 12.5 Weber. The correct option is B. 29th one. According to Faraday's law of electromagnetic induction, the EMF induced in the coil if an electric flux link with the coil. Wrong. Magnetic flux should be changes. Magnetic flux linked with the coil changes. Okay. Magnetic flux linked with the coil. Wrong. Magnetic flux linked with the coil must change, right? C is correct. Magnetic flux linked with the coil, and option D is also wrong. The correct option is C. Okay. And the last one. The current in a coil changes from 1 milliampere to 5 milliampere. So DI is equal to 5 milliampere minus 1 milliampere, that is 4 milliampere. And the time dt is equal to, change in time is 4 millisecond, that is 4 into 10 to the power minus 3 second. If the coefficient of self-inductance of the coil is 10 millihenry, that is L equal to 10 to the power minus 2 Henry. The magnitude of the self-induced EMF. Simple one, right? We know that L into I equal to N into phi, right? So now differentiate both sides with respect to t. Now L into di by dt is equal to N into d phi by dt. So what is N into d phi by dt? Rate of change of magnetic flux, right? So rate of change of magnetic flux is E, isn't it? That is self-induced in the induced EMF in the coil. So E equal to L is 10 to the power minus 2, and here L is 10 to the power minus 2 di by dt, right? Di is 4 into 10 to the power minus 3, right? 4 into 10 to the power minus 3 divided by dt is also 4 into 10 to the power minus 3. So now induced EMF E is equal to, here 4 into 10 to the power minus 3, 4 into 10 to the power minus 3 will get cancelled, right? So E equal to 10 to the power minus 2 Henry, isn't it? 10 to the power minus 2 Henry, that is 10 to the power minus 2 volt, that is 1 millivolt. Okay, 1 millivolt. So the correct option is D. That's it. Okay, so thank you so much for watching this video. If you love this video, please like and share, and if you want to watch more such videos, please subscribe. Thank you.